Our final example for today is example 4, where we're factoring trinomials. Note that the leading coefficient of each polynomial is 1. And what that means is we're going to use one basic technique. And tomorrow, our next class, we're going to look at factoring polynomials with a leading coefficient other than 1 and show you a different technique for that. The key here is to remember that these trinomials, or these expressions today, were the result of multiplying two binomials. This third term, the constant term, is a product, and this middle term is a sum. So what we're trying to think of is what two binomials multiply to equal q squared minus 3q minus 28. Well, let's start with the first term. What multiplies to make q squared is q times q. That wasn't the tricky part. Now, we got to find what numbers multiply to negative 28 but add to negative 3. Now, maybe you can think of this mentally. Maybe you can't. If you can't, here's how we'll think about it. Let's list the factors of negative 28. 1 times negative 28, 2 times negative 14, 4 times negative 7. Or we could just reverse the signs. Negative 1 times positive 28, negative 2 times 14, and negative 4 times 7. The key is which pair of these numbers multiply to negative 28 and at the same time add to negative 3. You see the answer is 4 and negative 7. So we have a positive 4 and a minus 7. There you go. We factored our trinomial. You can check by multiplying these out. Q times q is q squared. Q times negative 7 is negative 7q. 4 times q is plus 4q. Negative 7q plus 4q makes negative 3q. And 4 times negative 7 does make negative 28. Okay, moving to part B, hopefully we can recognize that this is the difference of two squares. And if you recognize that this is the difference of two squares, you can tell that our factors are going to be conjugates of each other. But maybe you don't recognize that. These are the difference of two squares, so here's what you can do. We can write this as r squared plus 0 times r minus 625. I reverse the numbers. Here we go. So what multiplies to make r squared is r times r. What numbers multiply to negative 625 but add to 0? Well, that's negative 25 and positive 25. Here we go. We can always check our factoring by multiplying these binomials, seeing if we get r squared minus 625. Last but not least, we've got the J4F problem, just for fun. A little challenge. It says factor x to the 4th power minus 81 completely. Well, let's see. What multiplies to make x to the 4th power? X squared times x squared. What multiplies to negative 81 but adds to that middle term 0? Well, positive 9 and negative 9, plus 9 and minus 9. Okay. We can't factor x squared plus 9 anymore. That's a sum of two squares. There's no factoring technique that'll work involving real numbers. But we can factor x squared minus 9 some more. What multiplies to x squared is x times x. What multiplies to negative 9 but adds to 0? Now positive 3 and negative 3. So see, this expression can be written as 3 factors. We can call this x squared plus 9 times x plus 3 times x minus 3. Thanks for watching the video. Good luck in your practice problems.